Hello. I am. We don't need the password. I am Choroba. I am from Prague, and half a year ago I started working for Good Data. I'm not going to present anything related to the firm, even if during a hackathon there I was able to work on this, my personal project. So it's called Karel, and it's an educational programming language that I re-implemented in Perl. And maybe I can, well, no. Let's do it and we'll see. Okay, so let's start with the question, what is an educational language? You can check on Wikipedia, there's a page listing all educational languages, and two minutes ago, when I ran make, there were 37 entries in the list under the children category, because there are educational languages for other categories of people as well. Well, this one belongs to the children category. Okay. So, what is? Probably I can do this as well. And this. So why Karel? It was invented by Richard E. Pattis at Stanford in the early 80s. I think it was the book was published in 81, I think. The book was called Karel the Robot, A Gentle Introduction to the Art of Programming. It was named Karel after Czech journalist, writer and playwright Karel Čapek, who is or was the author of a play RUR, which was quite famous at that time. It was in 1920 something in New York. And RUR, I should say this play is the first. It contains the first occurrence of the word robot, because he invented, or his brother, in fact, invented the word. And RUR is a firm in the play that produces robots, and RUR stands for Rossum's Universal Robots. So the name of the owner of the firm was also quite wisely chosen. And its Czech version, I mean the robot, not the play, became quite popular in Czechoslovakia. So why? It was the first programming language I learned. I spent my childhood in Czechoslovakia. And I implemented it years ago, like version 1 in Perl, but it was an interpreted language, and it was just one file of unmaintable regular expressions. So I wanted to try better. So now, how many people here are familiar with the language? Not many. Okay. So we will have a robot there that lives in a grid, and the grid can contain wars and marks. Marks were originally called beepers. And the robot can walk through wars, and the robot can pick or drop the marks or beepers. So it understands these basic simple commands. It can turn left, it can make one step forward, it can pick a mark or drop a mark if there's any, and it can stop. to make it more interesting, the robot can learn new commands. A new command is usually just a sequence of already known commands, or commands going to be known in near future. And there are also some control keywords that introduce loops. You can't really program without loops. So you can repeat a part of the code n times. You can use while and if with an optional else clause. And all these blocks that are run there end with done. The whole new command starts with command and ends with and. Conditions for while and if are of these forms, and you can use contracted forms as well. So something like while there is no mark, and you can also say if not facing south, and then do something. And this dialect of Karel also understands Perl-like commands. So example, our first Karel program. Command right, repeat 3 times left, done, and. So how it works. If you turn 3 times to the left, you in fact turn to the right. Because the grid is orthogonal. Okay. So calling a function. Calling a function is quite simple. It happens here. So we have command stairs when the robot just goes like this, diagonally. So while there's no wall, forward left, and if there's no wall, forward right. And right is something that we defined on the previous slide. And what's nice is that the robot remembers where a function was called from. So after turning left for 3 times, it goes back here, and so it works like a normal programming language as you would expect. And now the killer feature of the language, recursion. So you can call a function from itself. And again, it works the way you know recursion from other languages. So this is a bit more complicated. If you build a maze in the grid, the robot can use this to walk through the maze, touching, so to say, touching the right hand wall all the time. We can probably run a demo later to show that it really works. I have a maze prepared for the robot, and I can just use this code. So you can see that here we call the function itself. So as I said, it works as normally. And this means that Karel is Turing complete. So, homework. Number 1, implement increment and addition. We'll need it because without it we can't prove the Turing completeness. And number 2, write a program that fills all the accessible grid squares with marks. I'll show that it could be done in a demo, but I won't show you the code. I'll just show you the robot doing that. I'm kidding, but still, if you are interested, you can try it. It's not that hard, and in fact, you can find solutions on the internet, unfortunately. So, and now, why the heck am I talking about something like this on a Perl conference? So, implementation. So, this implementation of Karel is in fact a compiler, not an interpreter. So I used Marpa R2 for parsing the programs. I used test spec for tests. I used move for objects, and also in fact, the compiler doesn't compile the program to Perl. It compiles the program into some kind of an opcode or optree, what Karel optree, not Perl optree, and this optree is then run by Perl. And it uses stack to implement calling functions and recursion. So basically, in Marpa, you build some kind of lists of lists of lists of lists and so on. And when running them, you just clone a list onto stack, add some information, like when you want to repeat something several times, you have to count the times. So you add a counter to the stack, and that's how it works. So my question is, now, how many of you know Marpa R2? Not many. So I'll probably show you, yeah, but now I don't have, okay. So let's have some fun. Because I didn't know the resolution, so I know. Still too small? So let's use something really big. Okay, so you write your grammar in a rather readable way. So these are the non-terminals, these are the terminals, and non-terminals that are composed into like a higher non-terminal. And you associate an action with every rule, and the action is usually just a piece of code. So it's the name of a function defined here, and you can see these are the structures. So they are pretty simple. For the simple command, it's just a list with one letter that corresponds to what the robot should do. Repeat has R, then it has the number of repetitions and the enclosed code block to run. And that's it. So it's rather straightforward. Okay. Who knows that Spec? Not many, eh? Okay, so now I have to remember which file I wanted to show because it's not open anymore. Okay, so yeah, running maybe. Loading, no. Great. Let's try something and we'll see. Okay, so how it works. You just describe something, you prepare some code or some values that will be reused later, and then you say what this thing to do. So this is another good example because I'm testing some internal functions here, so let's move. But basically, you see, it empties the stack, and then there's code that should empty the stack and check it. But it should be quite easy to read what's going on from this. And there are some nice, but this one is something that I haven't seen before. Maybe it comes from something else, I don't know, but you can compare methods. So you can say that you have an object, and when you run direction on it, Okay, who knows who? Many of you, so let's pick it. I've already shown you. What's interesting is that this was tested on humans not only by me, but by all the previous implementators of the language. Well, I showed this to my 8-year-old son, and he was excited because he loves robots. And also, which was quite interesting, I was able to explain all-by-one error to him, which is something you wouldn't expect 8-year-olds to understand really. But when I told him that the robot can only turn left, he wanted to know what he should do to turn the robot to the right. So I let him think, and in the end he said, I know, I just have to turn left 4 times to the right. It was quite correct idea, but off by 1. So that was nice. And it also shows that I'm really his father because I quite prone to off by 1 error. Okay, so the current state of the project, version 0.03 is on its way to CPAN, which means the version with 2 at the end has already been loaded there, so you can download it and try it. The distribution contains a simple text user interface. I'll show you it in a second. And I have a nicer user interface on GitHub that's written in Dance 2 and Template Toolkit, but it's far from ready yet. So it's not on CPAN yet because I still have some work to do for the future. So what I wanted to add is debugging. When the robot is running the program, I wanted the GUI to show where in the source the robot is at each step. And it's not trivial. For interpreted language, it's quite simple. But for a compiled language, it gets complicated. Because from the grammar, you get the symbol positions and length. But you don't have the original source, which comes from, I'd say, the other end, and they should meet somewhere in the middle. And it's quite complicated. It's complicated the code. I can show you how complex we've seen these. So if I do you can see that it got a bit more complex because I have to propagate more information from the grammar into the document. But it almost works. So I wanted to make it work before the conference, but I didn't have enough time, as you can imagine. Oh, and I didn't talk to the microphone. I'm sorry for that. Which means the video will be silent, huh? Okay, that's life. Yeah, off by 1 is pretty bad, especially in case there's only 1. Yeah. Yeah, but it was like, you know. I didn't use it. It was my pride, and now I have to. Okay, so let's just see the GUI and be done. Okay, so that's how it looks. This is the robot. It's a blue arrow. Here we have the marks. I didn't say that you can stack the marks, so you can have 1 to 9 marks. And there are 2 kinds of walls. You can like change these walls, not by the robot but by the user interface. But you can never change the outer walls. They have to stay there because otherwise the robot would go off the grid, and that's something I don't know how to handle. So here we can run a simple command, like I can select forward, run it, and the robot makes 1 step. Let's do something more interesting. So can change the grid. Let me find a grid somewhere. There should be this, yeah. So it's a different grid. And now we can load in a source code somewhere. I have, for example, no, here. Okay, and this is one of the homeworks. Now the robot will fill the whole circle. It takes some time, so we'll probably won't see the full circle because it takes, I don't know, maybe 5 minutes, maybe more. Because the language can do everything, but usually in quite a stupid way. But still the source is like 7 or 8 lines only. And it uses recursion. You probably know the fill algorithm. Okay, so I'll show you the simple interface that's already on CPAN. Okay, so it's, you see it? Should I make it bigger? Is it okay? Okay, so you have a menu you can select from, and it works exactly the same way as the web interface. So I can load a grid. Okay, that's the last thing. So I have, for example, this one. It's a maze, and I can load a command. I'll use the same one as before, and now I'll run the fill command. And you can see this time it's not stepping over, it just finishes the command, and the whole maze is full, so it works. Quit. Quit. Okay.
Sorry, I was off that time.
Okay, no problem. In which way?
You have 1 minute.
Ah.
The next talk is finished in 50 minutes. You should finish the next 25 minutes.
Okay.
In case this projector doesn't work.
Which is not really probable. Okay, so future. After this, the robot will be equipped with a laser gun and will overload the humanity. Yeah. And I was quite in a hurry because I thought that we don't have enough time because of the problems. So we are at the end of the talk. So if you have any questions, we can return to anything, and I can give you details. Good. Yes.
What was the original use case for that language when it was made?
Education. As you can see, the name of the book shows it. a gentle introduction to the art of programming. So that was the original intent. Yeah, because Rossum was the name of the maker of the robots in the play. It's just a coincidence. Yep.
You plan to extend the game by having, if you come with a later in India, some counterparts of Python programmers?
Well, I don't know. I originally thought of making it possible to have several robots in one grid, for example. But I'm still not sure what to do with them. But everything is possible, yeah. Yep, comments. Not commands, but comments. Comments. I don't know how to, like here. This is a comment. I'll probably have wrong pronunciation. No other questions? So maybe I'll show you what I mean by debugging and by that we... Okay, thank you.
So if I would implement it, there are two ways to do it. One way would be to translate it to Perl program. And you went another way, I suppose.
Yeah, as I said, I create kind of an op tree that is later interpreted. But I didn't want to interpret the source directly. Because in fact this is my first compiler. I haven't written a compiler before, so it was a nice experience. Yeah, that was my intent, to write it in a way that it can serve to introduce you to how was it? A gentle introduction to the art of Perl programming. Yeah. So before you leave the room, I'll just show you the it's probably just proof the LT80. Oh, it's gone. It's in, no, in Git nothing is gone. Okay, the file is there. So something's wrong. Yeah, it fails the test, but still there is a command that should do left, 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 and you can see that the debugging shows the robot running each command. So that's the way how it works. Yep. Well, it does. It dies with an exception object that contains the location where the syntax error was. And as the parser, Marpa, is quite clever in giving you information about what it expected, what it passed so far. So all this information is included in the exception. So you can retrieve it and handle it as you like. Okay? So thank you.